Well, this is going to be a fast video on the quiz questions that were given today. The first one was how to change 1.5 meter cube into feet cube. And here's the answer. The answer here is very approximate. You don't actually get 53 feet cube, but the question says, what is the answer that is closest to 53? So that's how we get to the answer. Simple conversion there. And here, when you divide two numbers, the answer should have the lower number of significant figures, which is 2 in 0.74. So that's why that's the answer. Number 3, a car accelerates from 3 meters per second, no, that's 5 meters per second to 21 meters per second. So those are the initial and final velocities, and the acceleration is given. How far does it travel while accelerating? You have to find delta x. Here is the equation. On proper substitution and calculation, you should get delta x as (69 meters). So you have to know what terms are given, and you have to know which equation to use depending on the given terms. Here we have a question that talks about average speed for an 8.7 hour trip, but it says the first third of the trip chronologically, means time-wise, was driven at 96.5 kilometers per hour. What was the average speed for the rest of the journey? So first we take 1/3 of 8.7, which is 8.7 divided by 3, and then multiply that with 96.5 kilometers per hour. That will give us the distance for that first third. So here it is, the first third. The time is 8.7 divided by 3, which is 2.9 hours, and the distance is the average speed during that time multiplied by 2.9, which gives 279.85 kilometers. So 280, considering significant figures. Now, from the formula for average speed, total distance is the average speed for the whole journey, which is 73, multiplied by the time. So that is the total distance. Now, if we take the difference between them, we get the distance for the rest of the journey. And to find the average speed, you take the difference that's coming up right now, the difference between these two, divided by the difference in the time. And that would give the answer as 61 kilometers per hour. Here is a car traveling north at that velocity, 17.7 meters per second. And there is the final velocity in the same direction, so the sign doesn't change. The time is 12 seconds. We're asked to find the acceleration. Straightforward formula, change in velocity by time, that is acceleration. And when you substitute, remember it's final velocity, take away the initial. So you get a negative 0.30, which means the direction has changed. That means it's to the south. because originally it was moving to the north. And because you got a negative, it means it's now moving to the south. A ball is thrown straight up with a velocity of 39 meters per second. How much time passes before the ball strikes the ground? In this case, the net displacement is 0. The initial velocity is given. We know the acceleration is negative 9.8 meters per second squared. And you're asked to calculate time. Now the equation that has these 4 terms is this equation. And when you substitute into that equation and manipulate, you will get the answer for time as 8 seconds. So the answer is 8 seconds. Here's the 7th one. A test rocket is fired straight up from rest with an acceleration of 20 meters per second squared. After 4 seconds, the motor turns off, but the rocket continues to coast upward. What is the maximum height that the rocket reaches? Now there are 2 steps in this, as I've shown in the diagram. From A to B, it has an acceleration of 20 meters per second squared. After that, it just has the acceleration due to gravity, which is negative 9.8 from B to C. So let's do it step by step. For AB, we know that that is initial velocity is 0. A is given, find delta x during AB times 4 seconds. So use this equation and we can get the displacement during AB. (160 meters). Now for BC, the final velocity when it reaches B becomes the initial velocity for BC, right? So we got to find the final velocity at B, which is what I'm doing now. We know the acceleration is 20 times 4 seconds, so that would be the final velocity of B, which is the initial velocity of BC, right? And the final velocity at C is 0 because it stops before it returns. And A is negative 9.8 meters per second squared. And when we use this equation, you get the answer as 326.5 meters. And the total displacement is going to be the sum of these two, which comes out to be 487 meters considering sig figures. And here is an airplane that needs to reach a velocity of 203 kilometers per hour, and it's on a 2,000 meter runway. What is the acceleration required? First of all, got to change it into meter per second. Initial velocity is 0 and the final is 203 kilometer per hour. Changed into meter per second is 56.4 meter per second, and then delta x is 2,000 meter, and we have to find acceleration. So the equation is this one, which has the 4 terms. Substitute, rearrange, you will get the answer as 0.79 meter per second squared. And number 9, assuming equal rates of acceleration in both cases, how much further would you travel if braking from 56 miles per hour to rest than from 28 miles per hour? In fact, we can do this problem without any calculation, because we know from the equation that if the speed doubles, then the stopping distance quadruples because of the equation. But I'm going to do it from scratch. This is the equation that I'm talking about. You see that there is the square of the velocity related to the displacement. So if you double the velocity, look at this is the ratio. If you double it, then you just square it, it will become 4 times. But I'm doing it from scratch again. So this is case 1. We get that equation for case 1. When you substitute similarly for case 2, I'm calling this x1 and x2, and that's what we have to compare. The accelerations are the same because it said equal rates. Now you have 2 equations, A and B, and when you divide B by A, so you divide the left side by the left side and the right side by the right side. You see that the 2A and the 2A will get cancelled. So you got this divided by this is equal to, well, it's supposed to be x1 divided by x2. The way I've written it, it should be x2 divided by, x1 divided by x2. So x1 divided by x2. So that's actually dividing A by B. Anyways, we get the answers 4. Brings us to the last one. Here talks about a car crash where the car's velocity goes from 26 meters per second to 0 meters per second in 0.15 seconds. Let's find the acceleration. That's the initial, final is 0. Looking for acceleration, time is given as 0.15 seconds, which is really small. That's why the acceleration is going to be huge. This is the equation. That comes out to be negative 170 meter per second squared. But to find how many times this is of g, you just divided by the value of g, and you get it to be 17.68 g, which is 18 g. So those are the answers. I hope it makes sense to you and helps you to prepare for the exam. Thank you.